This video covers parabolas in vertex form. Please make sure to check your announcements so you know your due dates, deadlines, all that good stuff. So vertex form is the third form we're learning about. All right, it's the one that looks like this. If you have if you have colored pens or pencils, it might help you to color code the way that I am to help you to see things. There's a lot of patterns in this that will emerge as we're working. Now, the vertex form is really useful because it allows a person to quickly see the vertex of the parabola without any calculations. It also tells us the most information about the changes of the graph, which you're going to learn during the transformations form of this unit. Now, the vertex takes the h and the k that are here, and it puts them into an ordered pair. But the really important thing is that when you're writing the equations for the vertex or the AOS, you always need to flip the sign of the h value. The k stays the same, but the h flips. And that's because the negative that's here plays like an Uno reverse card on us. So what we're going to do is we're going to practice finding the vertex AOS and the direction that it opens, just here in vertex form. I know that we practiced a little bit with how it opens in 8A, so this is going to be just a little extra practice for us. So remember, the vertex is always an ordered pair. I'm going to take a look at this h value. It's a positive 2, so I flip the sign of it when I write the vertex, and I'm going to put a negative 2. Now the k value is this negative 6 out here, and it keeps its sign. For the axis of symmetry, you always have to write x equals, and then whatever number I put for h in the parentheses for the vertex, that's what I put for my AOS. Now, for direction of opening up or down, you have to look at this a value. If that a value is positive, it's going to open up, and if it's negative, the parabola opens down. Right? So a positive a makes us smile. A negative a makes us frown. So this a is positive, which makes our parabola happy. Let's try it again. So here's our a, here's our h, here's our k. So our vertex is going to be an ordered pair. The h value says negative 1, so when I flip the sign for that, I get a positive 1. And your k value is a positive 18. So my axis of symmetry is x equals, and then the 1 that I put in this blank. Now this makes kids a little confused with the a value here. The negative sign here, right, negativity brings us down, okay? The 2/3 here sometimes throws kids off. That makes it wider, guys. That's called a compression. So it makes your smile like this. Now this one and the next one, they look a little strange, okay? The minus in front here is still your a. The plus 2 in here is your h. But when I go to look for a k, there's nothing there. So what that means is that when I go to write out my vertex, I'm going to have a 0 where that k is because there's nothing there. Now my h, when I flip the sign, is a negative 2. So this parabola is going to look like, it's going to come down and kiss the vertex. Ooh, it's going to come up because it opens down. It's going to come up, kiss the vertex, and then go down like that. Now for my axis of symmetry, I have x equals, and I just put that negative 2 in here. And that negativity, like I just mentioned, makes us open down. Now when I go to color this one, it really tends to confuse kids a lot. Remember, your a is the number in front here, so if there's nothing written there, your a is a 1. And in this case, it's going to make your graph open up. Now my h is usually right here, right after the x, but there's nothing there. So what that means is when I go to write my vertex or my axis of symmetry, there's nothing there, so I put a 0 for that h value. And then in this last place, this negative 27 is a k. And I know that it's a k because it's not within the parentheses. And that is. So we're going to use that same skill, and now we're going to graph a little bit, okay? okay? So I'm color coding just like I did before. Here's A, here's H, here's K. And I'm just setting up my vertex and AOS because I know that those are the same kind of layout every time, right? My H is a positive 4, so when I flip that sign, I get a negative 4 for those values. And my K is a positive 3. So we're going to start by graphing that vertex onto our coordinate plane. Okay, so x equals negative 4 is this piece right here. Kind of hard to see. And then our vertex was at negative 4, 3. So I go 1, 2, 3, and there it is. And remember, if you write something on a graph, you want to make sure to label it. So I went ahead and labeled it. Now remember, we're trying to graph with 5 anchor points, so I've only found the first one. The next way that I get an anchor point is I am actually going to use this A value. So remember, this A value tells you when you go one box to the side, it tells you how far up or how far down to go. So this is saying go down by 2 units. So I'm putting my pen on my little vertex right there. I go 1 to the side, and with an A of negative 2, I go down 2. So this came from that A value. That's the point, negative 3, 1. And because parabolas are symmetrical across the axis of symmetry here, I know that if I went 1 box to the right here, I'm going to go 1 box to the left to have its reflection point. That's at negative 5, 1. So now I have 3 points out of my 5. Now to get the 5th point, we're usually going to just plug in another x value that we haven't used yet. So we've used negative 5, negative 4, and negative 3. My kind of tip or trick, right? A lot of times I'm tempted to put in 0 because that's a nice y-intercept. And I love me a good y-intercept. But with a parabola that's opening like this, that y-intercept's going to be like down, 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 like way off my graph. So to try to keep things near my graph, I need to pick an x value somewhat near my vertex. So I could pick negative 2 or a negative 6, and I'm probably guaranteed to have one of those on the graph paper. Okay, I'm going to pick negative 2 because it's a nice small number. So I come over to my equation, and I'm finding f of negative 2. So everywhere there's an x, I replace it with negative 2. And now I'm just simplifying this, okay? So first I'm going to clean up those parentheses because those are a hot mess. So right here, negative 2 plus 4 is 2. And then if you square that, I get a 4 here. So I've dealt with the parentheses, I dealt with the exponent. So now in PEMDAS, the next step is to deal with multiplication. So negative 2 times 4 is 8, negative 8, sorry. And then I add the 3 to that, and I get negative 5. So when I plugged negative 2 in, negative 5 was my output. So we can go ahead and we can graph that. Negative 2, negative 5, 1, 2, 3, 4, 5 is right here. And then because of the symmetry of the parabola, I know I went 2 boxes to the right of the axis of symmetry. So if I go 2 boxes to the left, I'll have another anchor point. That one's at negative 6, negative 5. And then we're all set to draw in our U shape. Remember, this is a U, not a V. So when you go to draw it, you want to make sure that the kind of tip of that parabola next to the vertex is nice and round. Also, make sure that you have arrows at the ends of your parabola to demonstrate that they continue on for forever. So that's how you graph it. Let's try it again. All right, so I'm adding my color coding just to help remind me what each value is and what it does. All right, I know my vertex is a point. My AOS is a line that says x equals. So if I start with the h value, I have a negative 2. So I'm flipping that sign to change it to positive. And then my k is negative 4, and he doesn't change signs. So we're going to graph those. And I'm using the same piece of graph paper because I don't have that much space. Okay, so x equals -2 is right here. Sorry, that's x equals +2. Silly Miss Caswell. The thing that's negative is the 4 from the vertex, right? Right there. Silly GoodNotes deleting things when you draw a circle on them. And then I wrote the wrong ordered pair. You would think Miss Caswell would not make silly goose mistakes like that. All right, so we have 1 out of our 5 points. So now to get our next point, we're going to use our a value. Now, these fractional a values are the ones that kids tend to mess up with. A lot of you guys think it acts just like slope, and you're like, ooh, rise 1, run 2, and that puts it there. But that's not true, okay? What the axis of symmetry, what the a value does is it only says when you go 1 box to the side of the vertex, you go up a half. So this actually puts your a value here, not there. So that's a big difference, right? Now, that does introduce us to having these icky, yucky ordered pairs, right? Like this is 3 and -3.5. This is 1 and -3.5. But that's something you kind of have to work past, you know what I'm saying? So now I have 3 out of my 5 ordered pairs. So now to get a 4th point, I'm going to pick another x value somewhat near that vertex, somewhat near 2, that I haven't used yet. So I've used 1, 2, 3. So I could choose to use 0, or I could choose to use 4. Okay? Those will both appear somewhere on the graph, somewhere near here. Okay? I'm going to pick 0 because that brings a lot of joy to my heart, because 0 is an easy number. So I'm coming on over here, and I'm finding f of 0. Everywhere there's an x, I'm erasing it and putting the number 0. All right, then we simplify the parentheses and its exponent. Okay, so right here, 0 minus 2 is -2. And then when you square that, that's like saying -2 times -2, which would be a +4, because a negative times a negative makes it positive. A lot of kids will plug it into a calculator. They'll type -2 squared. That's -4, y'all. So when you're using your calculator, when you go to square, you have to use parentheses to flip it to being positive, just so you know. All right. So now that I've done my parentheses and my exponent, I'm doing the multiplication part. So half of 4 is 2. Then I deal with addition and subtraction, which gives me -2 here. So my anchor point is 0, -2, which is right here. So when I go to do my reflection, this is 2 boxes from the axis of symmetry. So I'm going to come 2 boxes to the right, which is right here at 4, -2. And then I'm going to go ahead and draw my parabola, try to make it nice and round, and I draw the arrows at the ends. So that's graphing. This next part, guys, is sketching a picture and doing a word problem. We call this modeling. We're going to learn a lot about modeling in AE. So let's kind of walk through this. Oh, before I do, I wanted to add a little note. Sometimes when I'm doing problems that are pretty complex, I like to add notes to myself to remind myself what I did. So here I'm adding a note that says, pick a point near the vertex to help you stay on the graph. So that's just to remind myself how I did that. Anyway, so I have a golf ball. All right, so we're just going to kind of start drawing pictures, all right? So golf balls are usually hit while sitting on grass, okay? So here is my not very well-drawn grass. Okay, here's my little golf ball with this little golf ball divots. Now, when you hit a golf ball, right, it's going to come up, reach some maximum height, and then come down. It'll land somewhere over here. Okay, so what I want to do is I want to put this onto a coordinate plane. So the y-axis here is the height of the golf ball. And the x-axis is going to talk about the time. And I know it's talking about time because I have all these references talking about seconds. Man, my Apple Pencil's having a hard time writing, huh? I'm also going to say my height here is feet, just to remind myself what units I have. Okay, now I know that it goes 4 feet into the air. All right, so that 4 feet into the air would be its maximum height here, which would be the y value. I don't know what the x value is. I don't know how long to get to that maximum height, but I know that it goes 4 feet. And then it says it falls to the ground 10 seconds later. So that would be right here where it touches the ground. And the 10 goes into the x spot because that's the time. Now, because it's on the ground, I know that that's 0 for the y-axis, right? I also know my ball is starting at 0, 0 because it says I hit the golf ball from off of the ground. All right. So then if I keep reading, it says, we'll do it in pink. No, not pink. I've already used pink. Let's do orange. The question itself is asking, I don't have an orange highlighter. Miss Caswell. We'll get one, I guess. So this says, how high was the golf ball after 3 seconds on its trajectory? I don't know where 3 seconds is on this trajectory yet. I don't know if it's when it's still coming up or if it's after it's coming down. But I also don't know this piece here, which kind of bothers me. Now, I do know that the axis of symmetry is equidistant from the zeros, right? We know that those are the same distance away. So really, this vertex is halfway on this distance. So if the whole thing is 10, the halfway is 5. Ooh, I like that. So I'm going to put a 5 right there. So that means that when I'm talking about a trajectory 3 seconds later, it has to be somewhere over here, okay, where x is 3, and we're looking for that y value. I'm also going to add a little note to myself. Half of this distance. Okay, so now we got to find 3. So now I need an equation. Now we're in vertex form, so I'm going to go ahead and plug my vertex in. So our vertex was 5, 4, so I'm putting the 5 and the 4 in here. Oops. Now I don't know what A is, and that's an issue for me. So the way that we find A, because we need that in order to find the 3, is I'm going to take another point that I know that's on this. I could take the 10, 0, I could take the 0, 0. Either one will get me there. I'm going to use 0, 0 because I'm lazy and it's nice small numbers. And I'm going to plug in 0, 0. So f of x is the same thing as y, so I'm going to put a 0 there. And I'm going to put a 0 where x is. So here, I plugged in the vertex. And here, I plug in a known point. In this case, it's 0, 0, but it won't always be that. And so now I'm just going to kind of simplify stuff. I'm going to kind of clean it up. All right? I'm going to also help myself out. Here's my little river of Algebra 1 student tears. Just to remind me, like, to cross that river, I need to make sure that I use inverse operations. So I'm going to start by cleaning this up because it's real messy here. So 0 minus 5 is negative 5. And when I square that, I get a positive 25. Now I want to get A alone. I want to isolate that variable. So if I imagine the A as the center of an onion, this 4 is the furthest thing away. So using order of operations, I need to subtract the 4 to move it out of the way. And I know, guys, you're probably going to grouch at me because you're going to run out of writing space here. I'm sorry. I'm so sorry. All right, now this A is touching the 25, which means it's a type of multiplication. So to get rid of the 25, I have to divide to remove it. Now, negative 4/25, that fraction can't be reduced. I'm going to draw a little sad face because that's a yucky fraction. But it's correct. It's not anything bad. So now I can finish finally like writing my equation because my A value is now known. So there's the new equation. Now, I haven't answered my question yet, right? My question is asking me, what is it when 3 is the x value? So the last thing I gotta do is just take that equation I did all that work for, and where the letter x is, I'm gonna put 3's. Now we just solve this. Oh. Got a little too excited there. That's not a 3, Miss Caswell, that's a 5. Sometimes when we work too quickly, we make silly goose mistakes. Okay, so cleaning up those parentheses a little bit. 3 minus 5 is negative 2. And when you square that, you get a positive 4. Now, this word problem, right? If you ask me how high a golf ball is going to be, and you give me some weird fraction answer, I don't know what the fraction answer is here. I'm going to be like, that golf ball is 12/7 of a foot in the air. Like, I'm probably going to want to poke you in the eye. Honestly, like, that's annoying. So what I'm going to do here is I'm actually going to be simplifying this in using a calculator and just getting a decimal answer. All right, so you can't see my calculator, but I'm telling you what steps I'm doing. So here, okay, to multiply by 4, I convert it to a fraction, and I times my tops and then divide it by the bottoms, okay? So here I'm doing 4 times 4, which is 16, and then I'm dividing it by 25. Now that is a negative number because of the negative here. So that's negative 0.64, and then I'm adding 4 to it, which is 3.36. Now, because this is a word problem, I do need to make sure to give it a word answer. So I'm going to say the golf ball will be 3.36 feet above the ground after 3 seconds. So the more detail that you add when you're writing your answer out, the more clear it is that you understand what's going on here. Now, these real world problems, guys, almost every time it's easier to draw that picture first like I did, because it helps you to see like where you're going and what information you have. But there we have it. That is parabolas in vertex form.